work at the Vlaamse Landmaatschappij, the Flemish Land Agency, at the Department of Agro-Environmental Schemes. The EXPBIO project is funded by the EU Interreg Nordsee program. We are 8 partners from Sweden, Denmark, Germany, the Netherlands, and Belgium. We are municipalities, universities, botanical gardens, public research institutes, and governmental agencies. Our aim is to increase the biodiversity of the grasslands in the North Sea region because we are all concerned about the decline of grassland forests and are looking for ways to increase this. With this project, we are investigating the best management practices for improving and restoring flower-rich grasslands and want to give you tools on how to increase local plant communities. Last week, I told you about plant blindness. There's a tendency for people to be more interested in animals than plants. I'm very pleased to see that the attendance to this webinar series shows that there is growing interest in grassland plant diversity. This spring, we held a series of webinars on seed mixtures and seed cultivation, and now we have the second webinar series focusing on grassland restoration. 6 speakers share their latest insights on how we can rediversify the grasslands in Northwest Europe. Last week, we listened to the webinar of Hans de Kroon, focusing on nature restoration on dikes. And this week, Anne Schrijver is here to talk about restoring species-rich grasslands from science to practice. Anne Schrijver is a lecturer in nature management and restoration and a researcher at the HOGENT, University of Applied Sciences and Arts. In her work, she consistently pursues practice-oriented solutions to real societal challenges. This webinar is focusing on actionable tools for nature and green space managers and also how farmers who play a key role in day-to-day management of the most grasslands, how they can benefit from more diverse grasslands. Whether you manage nature reserves, public green spaces, or agricultural landscapes, you will gain clear guidance for achieving practical results in the fields. So this webinar will last 1 hour. 30 to 40 minutes for the presentation, and the rest for the time is for discussion. Just some technical issues. Gunilla Hell-Bellman is in charge of the technical aspects. You see her on the screen, and she will ensure that everything runs smoothly. We ask you to mute your microphone and to use the chat for communication and the discussion. So with that, I hand over to you, Anne.
Thank you very much. And thank you all for being here. I would like to start my talk with this graph. It's a chart that shows the conservation status of the habitats across the European member states. And green means good, yellow is unfavorable, and red is poor. So you see that Romania is doing very well, but Belgium, where I come from, is at the bottom of this graph, so is not so doing well. It's performing much worse than the European average. So let's first take a look then at the grasslands in Belgium. So what is the conservation status of grasslands in Flanders? So Flanders is the northern part of Belgium, so of my country. And then you see for some typical European habitats, grassland habitats, that all these habitat types are really doing really poor or unfavorable. We saw these numbers and we wanted to know, okay, what is going on? What does that mean, a bad conservation status? And so we wanted to see it ourselves, what is happening. And we studied 42 lowland hay meadows. And we wondered, are these 42 hay meadows spread over Flanders in a favorable conservation status. Then, of course, the first question is, what is that, a favorable conservation status? What does this mean? And in Belgium, we have very interesting reports made by the Institute of Nature and Forest Research with some criteria saying what does that mean, a good condition or a favorable conservation status. And in this report, there are a lot of tables like this one with, for example, the key species for this habitat type. And you see a long list of typical species for this typical grassland. In other tables, there is stated then that we should have at least 7 of these typical key species with a combined cover of at least 30%. So if we have 7 key species and they all together have a cover of 30%, then one criteria for a favorable conservation status is met. So about which species are we speaking? These are a number of species that should occur in these grasslands, and we looked for them in these 42 grasslands, and in only 22 of the 42 grasslands there were at least 7 species of them, and in only 10 of them they had a cover of at least 30%. So how comes that these species are gone or aren't still there? What is causing that so few species are present there? And of course, if you look into the literature, you can find a lot of information about that. For example, this very interesting study of Carly Stevens of the UK, who showed very clearly that when nitrogen depositions increase, you see a linear decrease of species richness. Looking for Flanders, then, we have really beautiful maps of the nitrogen depositions in which we see that they range between 15 and more than 50 kilograms per hectare per year. And we see some zones in our country which are coloring quite red. And these are typically the zones of a lot of animal husbandry, so high emissions of ammonia, which are deposited very locally. And we also can see the traffic roads. Here, the main depositions are coming from nitrogen oxides. So we see these 2 hotspots here in the western part and in the northeastern part. And unfortunately, there, the most vulnerable nature is situated. So there in the eastern part and in the western part of the country, where depositions are very high, we see that the most vulnerable ecosystems like Molinia fen meadows or heathlands or Naudus grasslands are situated. So these nutrient-poor grasslands, they can only handle about 10 kilograms nitrogen per hectare per year, and often their measurements are above 40 or 50 kilograms. So we have beautiful reports also from the Netherlands with critical deposition values, with also the tables with all the grassland habitats stating how much nitrogen can come in before diversity decreases. And for our 42 grasslands that we were studying, we know that they can receive a maximum of about 20 kilograms, so 19 kilograms, before diversity decreases. So we check the numbers, how much nitrogen is coming in these grasslands, and only for 21 of these grasslands, the depositions were lower than these critical levels. So for Flanders, it's a bit of a sad story, but if we look at our history, then we see that we have some encouraging numbers to show, because this was the past. So this was our map of nitrogen depositions in the 1990s, while now it's coloring more green, more blue, and depositions already decreased substantially over the past decades. But we are not yet there, and our grasslands are still suffering. It's not only nitrogen that is a problem for plant diversity. Also, phosphorus is a big problem. Phosphorus does not come with atmospheric depositions, but it always is a legacy of a former fertilization. So if grasslands are or were in the past fertilized by farmers, for example, by organic or by chemical fertilizers, then you can always find back high phosphorus concentrations in the soil. And these are quite persistent over there. So this paper shows the decrease in plant species richness when the plant available phosphor concentrations increase. And you don't see a quite linear decrease, but you see it's like a kind of a threshold that once this threshold is exceeded, you see a much lower number of species. So we have in our 42 grasslands, we have 31 of them with too high concentrations of phosphorus in the soil. So these species aren't there, too high nitrogen concentrations, too high phosphorus concentration. Maybe I can first explain you a bit why is high nitrogen, why is high phosphorus concentrations in the soil so bad for plant diversity, because all plants need nutrients to grow, and why or how comes that too much is too much. So in natural conditions, without high depositions of nitrogen and without fertilization, in Flanders, but also in the rest of European countries, most conditions are nutrient poor. So most soils are, from natural conditions, nutrient poor. And a lot of species have developed several tricks to get nutrients out of the soil in these nutrient poor conditions. So we have, for example, nitrogen fixing species like red clover that take nitrogen from the air. We also have other species that are releasing root acids or enzymes to mobilize bound nutrients in the soil. We also have species that are connecting with mycorrhiza and so enlarging the root surface. And we also have hemiparasites like yellow rattle that tap nutrients and water from a host plant. So in nutrient poor soil conditions, there is competition for nitrogen. We know that there is competition for nutrients, for nitrogen and for phosphorus. And all these plant species have some tricks to cope with it. So these strategies, they create a kind of a niche differentiation. They have multiple ways to make a living over there. And so many species can share the same soil, the same place. When then nitrogen comes out of the atmosphere by nitrogen depositions, for example, or soil is fertilized by organic or by inorganic fertilizers, everything changes because all these tricks are not necessary anymore. So when we add nitrogen or phosphorus or the both, the balance collapses. So what happens? A few competitive species that can grow very, very fast can quickly dominate the vegetation. And they can take a lot of light for the herbs that are present over there, but also light for seeds to germinate. So what we see is you see a shift from competition for nutrients towards competition for light. And that causes a lot of grasses in our ecosystems, and according to our tables in our report, the dominant grasses to be in a favorable condition or conservation status, the dominant grasses or the cover of the dominant grasses should not be over the 50%. So if we have more than 50% of dominant grasses, the grassland is not longer in a favorable conservation status. So in our 42 grasslands, in 25 of them, there were more than 50% grasses. So if we add nutrients to such a beautiful grassland, there will come a lot of grasses. But the same thing happens in road verges where nitrogen deposition comes from traffic or agricultural. Also here, this will lead to dominance of grasses. And also in your lawn, if you want to get rid of your herbs in your lawn, you can apply fertilizer and they will quickly disappear because grasses are more fast growing and take off the light for the herbs. So such a highly grass-dominated grassland often still produces a lot of biomass. So in our grasslands, we see that they often still have a high biomass production of 7 to 9 ton dry biomass per hectare. They show a low biodiversity. And the food web is simple and lacks complexity. It lacks ecological complexity. What we want are grasslands like this. Beautiful grasslands with many, many species and of course also a lot of associated diversity, a lot of insects eating birds, and so on and so on. So what we want is this with a complex food web. And this complex food web, it all starts with the diversity of the grassland vegetation. So here. Just to show you one more depressing number before we go to the next part of our talk. The fact that we don't have many flowers in our landscape causes a lot of butterfly species to collapse. So here you see the butterfly species in Flanders. There were about 75 in number, and about 1/4 of them are already got extinct. Another 1/4 is in danger, and about the half of our butterflies are doing still well. So we have not so many key species. We have a lot of grasses. We have much nitrogen and phosphorus coming. That is coming from the air, nitrogen and phosphorus as a legacy of former agricultural use. And still another challenging thing for our grasslands is the fact that groundwater levels are also a major concern. So many grasslands are affected by drought. So here, for example, you see the situation in Flanders in the summer of 2025, where groundwater levels across Flanders were decreased and where groundwater levels were very low. In wintertime, we then see the reverse, the opposite, where we have wet conditions, also some floodings, and these are quite confusing conditions for grassland species. So if we go back to our 42 grasslands that we studied, then as a whole, only 1 out of 42 was in a favorable conservation status. And then we thought, is it hopeless? What can we do? There must be something we can do. We know that if we want to go from the left to the right, it only takes nutrients to be added to the grasslands. But how can we go back? Are there or aren't there good practices we can take so we can reverse this situation? That was our question, and this was also a question of nature managers who came to us and said, what can we do? We are here mowing for many, many years, and we only see grasses, 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 grasses. No key species are coming back. What are we doing wrong? So therefore, we set up experiment in 2017, and this experiment is conducted out in 3 field experiments, or 3 fields nearby our university college, so that it's not too far away, so we can go there with our students to measure and to monitor and to look at what is going on. So 3 sites with each 30 plots. Each plot is 5 meter on 4 meter, and the plots are divided by paths that are mown more frequently. So all these 3 sites, they had an agricultural past, so there is too much phosphorus in the soil. Also, there are some nitrogen depositions coming from the atmosphere. We have too much phosphorus in the site at Melle, and in Gembrugge and Makkegem we also have too much phosphorus, but especially in Melle, phosphorus conditions were really, really high. All grasslands, when we started our experiment, looked like this. So they were all dominated by grasses, by competitive grasses, and only a few herb species were present. So this is our experimental setup in our 3 sites. I will not explain this in detail, but through my talk I will show you some results. I will just show you that the plots with the blue lines, they are mown frequently, so they are mown 3 times, and with a first cut in early May, so in the beginning of May. The green plots, they are mown 2 times. So it's a kind of a standard mowing method that is being used in Flanders by a lot of nature managers. So they are mown 2 times, and the first cut is at the end of June or the beginning of July. Then you see also brown plots, and these brown plots, there we have cut back the vegetation. So we did some sod cutting to take away the dominant grasses over there. And then you also see some plots where we have some dots in it. These are plots where we have reintroduced species by seed or by hay. Okay? So what are we measuring? We measure there a lot of things, but among all these measurements, we sample the above ground biomass, we cut back the vegetation, or we clip the vegetation in small quadrats, we dry the material, we measure the above ground biomass production, we grind the subsample and we analyze nutrients on it, mainly nitrogen, phosphorus and potassium, but also calcium, magnesium and so on. And we also do some standard forage quality measurements like the protein content and the energy amount, the energy index. We also do vegetation surveys each year. This is my colleague Aaron. He's a specialist in vegetation surveys. This is one of our students who came to help us. So we note all species that are occurring in the plot, and we also score the cover per species. So we wanted to deliver answers to our managers on how they can retransform these grassy environments into species-rich grasslands. And the first question we had was, how can we push back these competitive grasses? And the first method we tested was performing an early cut. So the first cut early in the year, before the 15th of May, in comparison to a first late cut after the 15th of June. This method was not our idea to test, but it came from our Dutch colleagues, Wim Schippers, who already suggested this as a good measure in his very interesting booklet, Development of Species-Rich Grasslands. And he explained in his booklet also why this might work. So this picture shows different grass species that are occurring in grasslands. And you see that the grasses in bold are quite mostly competitive grasses. And a lot of them already flower in May. So here you see on the x-axis the months. And in May, a lot of these competitive grasses are already flowering. So are already entering the bloom. So it's about Ochus lanatus, Arenatherium melaceus, Alopecurius platensis. So when they are flowering, they have invested heavily above ground. So they have a lot of, they took a lot of energy and a lot of proteins above ground. And if you then cut them back in May, in early May, you can kick them back. So you hurt the grasses. As a result, you can create more space for herbs and forbs later in the season and for the next year. So this was a theory that by cutting back them in early of May, we could hurt them, especially these competitive grasses. Of course, it's not the case for all grasses. Some grasses like Agrostis solonifera, they flower only later in the year, and they only invest a lot of energy also later in the year, just starting from June. So what did we see in our 3 experimental sites? We saw that for a late cut or an early mowing date, so these are 3 times cuttings with the first cut before 15th of May, and the green line are 2 cuts with a late mowing after 15th of June. We see that the percentage of grasses was significantly lower when we did 3 cuts with this early cut before 15th of May. And in here in Melle, it's a bit a complicated situation because we have large floodings over there. So conditions are not optimal. And there also we see, because of these floodings, a lot of Agrostis solonifera, which is just like doing better when you do an early cut. So what about the herbs then? If you do an early cut, you might think that herbs are only also affected, but that's not the case. What we see is that the herbs, or the percentage of herb in comparison to 2017, so the start of our experiment, that the herbs are quite doing well or not doing worse compared to a late cutting. What we also discovered is that these early cuts not only set back the grasses, but also has a quite good forage quality. We have in our data, we could see that the digestible proteins were about 70% higher when you cut or you mow in May compared to a late mowing, and also the energy amount is remarkably higher. How can we push back the competitive grasses? So this early first cut was our first method. The second method was introduction of Rhinanthus angustifolia. So this species, you probably all know it, yellow rattle, is an annual that germinates in the spring and quickly forms hostorial connections to surrounding grasses and also to red clover. And then it taps water and nutrients, and as that it reduces or it can potentially also reduce grass growth, which lowers or should lower the competition. So in our data, we also saw that the presence of Rhinanthus shows the same suppression of grasses as an early cut. So these are comparable results. Yeah. Rhinanthus angustifolia is not establishing everywhere very easily. You should already have a quite low biomass production. According to literature, it should be quite modest, lower than 6 tons dry mass per hectare, and there must be some open gaps because it's an annual species. In our trials, it only initially appeared in the plots where we cut back the sward, so where we did some sod cutting, and there bare soil was available, and there these yellow rattles came up and could also over there do their work. if we put nutrients to such a grassland, we know that it will have a lot of grasses. Question is, what is good management and to turn it back to the left side of our screen? How can we get back the species? So get rid of the grasses, we can try an early cut, or we do Rhinanthus introductions. The second question is, of course, how do we get back all these lovely flower species, all these herbs? So how do we get the herbs back? And it's about this species. We would like to have back. And there is a big constraint because these, a lot of these species, they only have a short-lived seed bank, typically only 1 to 2 years, seldom more than 5 years. And after a long agricultural use, they have disappeared often. We also have this situation in Flanders where we have a lot of fragmentation. So this is the degree of urbanization in our country. So a lot of villages, a lot of towns, we have roads, we have industry. In between, we have then the agricultural practice, and there in between we have our nature reserves. And the result, of course, is low connectivity and limited dispersal of species within this splinter bomb, you can say. So it's not so easy to get all these species back there. First of all, because of the fragmentation, so they won't come back on their own. But secondly, also because the seed bank is for a lot of these species empty. And what we see in our grasslands is that species with a long-lived seed bank, for example, Ranunculus repens and Cerastium fontanum, Plantaga lanceolata, Rumix acetosa, these species, they are coming back quite easily in the grassland. But the key species of here, the really key species of our table, of our reports, Knausia arvensis, Campanula rapunculus, and so on, we can still keep waiting for them. They will not come back easily because of the reasons I told you before. So will we keep waiting? As scientists, we have the idea we cannot keep waiting. We should do something. We should consider reintroductions of these plant species. And therefore, because nature managers were also asking, how should we do that? Should we use seeds, or should we use a hay transfer? What should we do? So therefore, we split up our reintroduction plots in two, and in the one part we introduced hay, a hay of some nearby species-rich meadows. And in the other part of the plot, we introduced seeds. So in the same plot, we could then compare the two methods. So we collected hay from several meadows within the same ecoregion of our grasslands, and we collected green hay and also soil, but I will not go deeper into this, but we also collected soil and we reintroduced this into our plots. And what could we conclude? Well, I show you my last graphs. Here are the number of key species on the y-axis, and on the x-axis you see so the start of our experiment in 2017, where we did a reintroduction. We again reintroduced the species in 2018. So reintroduction occurred 2 times, and then we did not do anything. We just waited and see. And what we saw is that the control plots are the green dots and green lines. The hay transfer is this one, and the seed transfer is this one. So what we see is that both hay transfer and seed transfer are quite doing well. We see that in one of our sites we already have this number of at least 7 key species present over there, so they are evolving into a favorable condition already after 1, 2, 3, 4, 5, 6 years. And also the cover evolved quite well, and you see that the criteria for being in a favorable condition of at least 30% was also met in some of our plots. Not in Melle because of the mentioned difficulties here. Flooding for a long time, for months, is really not improving the species richness of these grasslands. So what we have are in our experiments are both nowadays very grassy plots and just nearby very flower-rich grasslands. And this is really great because we can show the impact of some quite simple measurements on species richness to our nature managers. So we do a lot of excursions over there, and these are one of our most beautiful plots where we have a lot of species and a lot of cover of these species. And I know it's difficult to make a good photograph of it, but I hope you get a little bit the impression of the difference compared to the picture I showed you before. So we go over there with nature managers, we organize courses, we explain our results, and we hope to inspire managers, and we stimulate them to try our good practices out on their fields so we can validate our results also. What we also see is that when more herbs are in the hay, the forage quality is quite well. So we have split up our biomass samples, herbs versus grasses, and then we could see what was the effect on the digestible proteins, for example, and the calcium concentrations, for example, when the number of herbs are increasing. So the digestible proteins were not doing worse compared to very grassy samples, and also the calcium concentrations were doing quite well. So an increase in calcium concentrations when the number of, or the percentage of herbs increased in our samples. So to conclude, an early cut reduces the grass dominance in our plots. Yellow rattle also does, but it's not so easy to get it in such a very grassy environment. So the early cut also gives a good forage quality. Addition of seed and hay also works both very well, especially seed addition works, because with addition of hay you also are introducing a lot of seeds of grasses. And you see that the grass dominance increases in the beginning. More herbs is not really bad for forage quality, is sometimes even beneficial. And what we see and where we are really delighted for is that we have lovely flower-rich plots after 9 years. And some of these plots are reaching favorable conservation state. And this is, according to our opinion, really, really great. So we also have a lot of insect species in these plots. We summarized our results on our website, but it's in Dutch, unfortunately for you. So it's in Dutch still now. We are also working on scientific papers, but they will be published in the coming years. This is the end of my story, and I would like to ask you if you still have any questions for me.
Thank you, Anne, for the very interesting talk. I will start with a question. What do you see as the most important challenge in the short term?
One of our main conclusions is that also when you have high phosphorus concentrations in the soil, you can have beautifully flower-rich grasslands if you do the right measurements. But for example, in 2024, it was here in Belgium a very warm and a very wet year, and then you see that the grass dominance that decreased in the last years increased again, just because the conditions were really ideal for grasses to grow again. So according to us, it's really very, very important that if you have nutrient poor grasslands in your country, that you try to conserve them, to protect them maximally, because low nutrient concentrations, low phosphorus concentrations are the most sustainable solution for species-rich grasslands. And you can do something, but what the effect will be also on soils with higher phosphorus concentrations, it's really depending on the management you will perform. So you have to continue good management, and it stays fighting the nutrients in the soil.
Okay, I will look at the questions in the chat. For sowing or the hay, you need naked ground. Did you take away the existing grasses before? And secondly, what was the moment you did the seeding, spring or autumn?
Yeah. So we took away the grass layer just by sod cuttings, just by using a machine that also gardeners use to construct flower-rich meadows in gardens. And then the soil was bare, and then we put in the hay and the seeds, and we did it after the hay was collected in the meadows where we collected the hay. So it was first time in the summer and the second time in autumn. So we transferred the hay 2 times. And also the seeding was then added in the autumn, so not in springtime.
And then a question related with this. Can you recommend other management before sowing of herbs other than mowing? And how did you do the management just after the sowing?
So the management after the sowing was, or it was 3 times cutting, or it was 2 times cutting. So this was just our experiment. The comparisons between the cuttings was independently of whether we sow or not. So it were several combinations. Some plots were introduced and were cutted 3 times. Some plots were introduced and were cutted 2 times. Some plots were introduced and were so different combinations of our both the timing of cuttings and the introductions were made, so that we can see what of our measurements were working best.
And then another question, when you have a very nice grassland with a lot of flowers, will you mow it so early, or will you let all the nice species grow?
Yeah, that's a really really interesting question, and we were also a bit worried that when we cut back the very beautiful grasslands back, when we cut them already in May, we would lose species, but that's not the case. Species are just staying over there. They can perfectly handle the early cut, and what we see is that they flower later on the year. So the plots that were introduced and are cut or are mown late, so at the end of June, they flower first, and then later on, so starting from half of June, the plots that were cut back in May, they start to flower. And that's really, really interesting, because you have on a small a small experiment of us, you can see flowers during the complete season. So early in some plots and later in the plots that were cut back in May. And that I think you should try to do on a landscape scale, that you have some plots cutting back early, cutting back late, so that you prolong the amount of flowers in the landscape, that it's not quite that you don't create an ecological trap by mowing back everything. So you can choose for mowing in your parcel and leaving some parts that you don't mow, but you can also do that on a landscape level. We see a very interesting results with that, and impact on insects also.
Another question, how do you determine the best timing for the additional early cut?
Yeah. That's a good question, because you cannot just say you should mow, for example, 5th of May. We say you should do an early cut, and you should do it before 15th of May, approximately, because some years conditions are different from other years. If you have wet and warm conditions, it might be already possible to mow, for example, in the beginning of May. If you have a dry season, it might be later. So what we do is we look at so we also work together with agricultural experts, and we ask their opinion, and they say you should just mow when you have the first flowers in the grass appearing. So some years it's beginning of May, other years it's half May. So it depends.
And then have you looked at the nitrogen amount in the roots in your experiment, or are you planning to?
We did not yet do that. It might be very interesting to do that, but it's a lot of work. And the thing is that we are continuing our experiment during the coming years, and we will do a lot of measurements, and that might be one of the possibilities. So maybe in the future.
A question about one of the graphs of Henbrugge and Makkehamse Meersen. What is the reason for the recovery of grass dominance in 2024 and 2025, despite of the early cuts?
Yeah, that's really remarkable. We see an increase in dominance of grasses again in 2024, indeed. And that was because it was a very warm and wet spring. And that's what I tried to explain before, that if you have low phosphorus conditions in the soil, these dominance of grasses will not occur. But if you have a high, and these in our plots, all plots have too high phosphorus concentrations in the soil. If you then have ideal conditions for the grasses, so wet and so warm, then again they can come up. Even if they were pushed back the years before, they will come back, and then you still need to keep on doing this first early cuts. And we see this year that it was already less than in 2024. But it's challenging.
How many species did you sow in the experimental plots?
I don't know by head, but I show you the picture. Wait, I'm sorry. But these species were sown in the plots. And we also are now, this year, we will put in some plug plants. So the plants, so we will start experimenting not with hay and with seed, but with plug plants, so that we're growing with seeds that was collected in the neighborhood of our experimental sites.
And someone wonders if you have already applied these methods in the 45 meadows in Belgium that you showed at the beginning.
No, we did not yet, but we started to give a lot of lectures and a lot of courses, also grassland courses for managers, and we stimulate all these managers to start just to start and to try our methods, just to have a kind of a validation. So we hope that we get some input the coming years.
Are there any articles available on the tests?
Only in Dutch. On our website, the English articles are, work in progress.
Did you remove the hay after inoculating?
We left the hay there for a week, and then we removed it.
Are you planning of seeding of drought-resistant plants also?
Yes, in Gembrugge we will do that, because now we get to know the hydrology of our site also very well. We have piezometers in each site, and we get now good insight in the fluctuations of the groundwater, and we indeed will start specifically in Gembrugge with reintroduction of some drought-resistant species.
And then a last question about the height of the cutting.
Yes, so we cut, it's about 7-8 centimeters we cut. So not too low, not too high. It's, yeah, 7-8 centimeters.
I see 2 people raised their hand, so maybe we have time for 2 last questions.
Of course.
Irina?
First of all, I would like to thank you for the very interesting presentation. And my question is regarding with the species that you said it is very important, right? Rhinanthus angustifolias for its conservation. What is the reason that this species is particularly important? It is endangered species or what?
I'm sorry, which species do you mean? The Rhinanthus species?
Yes, Rhinanthus. You said that this is very important, but it was a little bit difficult to reintroduce them. So
Yeah.
I was wondering, just why it is important.
Yeah,
Thank
so no problem. So Rhinanthus is hemiparasitic species, so it can suppress grasses because it has hostoria and it takes off water and nutrients from grasses. So if you get Rhinanthus in your vegetation, it can suppress the grasses. But it's not so, it's an annual species, so it's not very easy to get it into your vegetation because it needs conditions that are not too, the biomass production may not be too high. So introducing Rhinanthus in the grassy plots we had in the beginning was not successful. It only occurred where we cut back the grassy vegetation, so we did some sod cutting, and there it could establish because it also needs some bare soil to be able to germinate. And the thing is also that you cannot combine Rhinanthus with an early cut because then you lose it. So it's an annual, you have to let it get seeds and then you can mow it. Was this clear enough?
Yes, thank you so much. Thank you.
And then Irina? There is a hand raised, but maybe it wasn't.
Wait, sorry, no, it's okay. It's just I'm a bit confused with microphones and technologies in general. Thank you very much for leading me into the meeting. At the beginning, I couldn't join. It was a very interesting talk. Thank you very much. Very beautifully designed experiment, which is not very often we see around in these days. The question I've got, because I missed the beginning, unfortunately, are those 3 sites you mentioned, and one has been flooded badly, and so it didn't do well in restoration terms. What about 2 other sites? Are they out of the floodplains? They are not flooded? They're dry grasslands? Thank you.
Yeah. So one of them is quite dry during the complete year. That one is performing best. So this was our Makagem site. This is, I will show you. So here, this one is the most dry site. Mel is flooded and Gembrugge is as groundwater until the mowing level in wintertime, and in summertime it falls back for about 1 meter. But here also Gembrugge is more recently taken out of agricultural use compared to Makkegem, and it goes slower. The restoration goes slower there, and we think that it is because of the legacy of the agricultural practices. Makkegem was already longer in nature management compared to Gembrugge.
Okay. Thank you very much. Thank you. It's important how long and for how long the sites are flooded and the level of groundwater, as you mentioned.
Yes,
Thank
indeed.
you.
You're welcome.
So if we haven't answered all the questions from the chat, we will have a look at it and we will put the answers on the Interreg website. Thank you very much, Anne, for the interesting talk.
With pleasure. Thank you for inviting me.
So next week we will listen to Karin Amsten on the subject of fire and herbivory, key drivers of temperate open ecosystems. If you would like to attend other webinars of this webinar series, please register for each and every webinar you would like to attend. All the webinars will be recorded and can later be seen on the webpage of EXPBIO. And after this whole webinar series is accomplished, you will receive an email questionnaire on reflections and learnings. We would appreciate it very much if you could fill it in, as it really helps us to make recommendations for future steps for biodiversity. So your answers are very important to us. So you can still use the chat for another few minutes if you have any remaining thoughts to share, and we will check it afterwards. So thank you very much of the entire EXPBIO team for joining us, and you're welcome to the coming webinars. So bye.